The new pedestal is a replica of the original 1854 pedestal with hidden modern features to improve maintenance requirements. The water jet process is used to cut thick steel and aluminum plates used in the base assembly, clockwork cabinet, and upper cabinet assemblies. The welding process is used on the base assembly upper cabinet column, the rotation hub, and the fan legs used to support the lens. Support arms for the fan legs are bolted directly to the rotation hub. The base assembly is constructed of welded structural steel and bolted components. The clockwork cabinet is constructed of structural steel columns and machined aluminum doors and shrouding. The bearing to provide rotation to the lens is mounted on top of the clockwork cabinet, the pinion gear to provide torque from the motor, and lubrication pinion to distribute grease to the gear teeth. The metal components are painted green to match the historic pedestal, and the same color that was used by the United States Lighthouse Service. Cast aluminum shrouds were manufactured to represent the cast iron riser that was used on the original pedestal. These are removable to gain access to the drive motor. A welded structural steel column and machined gussets are used to support the upper cabinet assembly. The rotation hub assembly is used to support the fan legs and lens assembly. The rotation hub is mounted on top of the bearing and upper cabinet column to the top of the clockwork cabinet. Chariot wheels were used as the original bearing system, along with the bull gear that rode along the top of the chariot wheels, providing rotation to the lens. The upper cabinet is mounted at the top of the pedestal and provided access to the lamp and inside of the lens. The lamp controller and lubrication system are located inside the upper cabinet. The counterweight system was used to drive the clockwork assembly, which provided rotation to the lens. The control cabinet is used to operate the drive motor, lamp, and lubrication system. The SLU-36 lamp will provide the light source needed to project the 24 beams of light from the lens. At the time the original lens was put into operation, a clockwork mechanism was used to provide rotation to the lens. This clockwork and counterweight system will be used for exhibit purposes only. The lens rotation will be provided by a hidden motor at the base of the pedestal. The replica clockwork will demonstrate to visitors how the lens operated when first exhibited in the late 1800s. The drive motor is located in the base assembly. The modern bearing will support the weight of the lens and provide the rotation. The chariot wheels will operate as they did on the original pedestal, but will not carry any load. First-order lenses were designed with a skeletal framework to support the prism panels. The prisms are CNC machined in PMMA acrylic material. The acrylic material is UV stable and has the same optical refraction properties of the crown glass used in the 1800s. The prisms are set and isolated from the framework using silicone shims. Epoxy is used to secure the prism to the framework. There are 24 lower prism panels, 24 bullseye panels, and 24 upper prism panels, for a total of 24 top-to-bottom flash panels arrayed around the entire lens. The entire lens contains 1008 optical elements. The upper prism panels are offset by 3 degrees to lengthen the duration of the flash. The lens will project a beam of light from each flash panel for a total of 24 beams of light visible 20 miles out to sea. The lens will rotate once every 4 minutes, exhibiting a flash every 10 seconds.